Hello and welcome to Biological. This video explains how ions form and how we get ionic bonding. It follows on from my videos on elements, compounds and bonding, and another on single and double covalent bonding, so you may want to check those out first if you haven't already. We've already seen that atoms contain a nucleus with positively charged particles called protons. But there are also other particles in the nucleus called neutrons, and as their name neutron suggests, they don't have a charge. In other words, they're neutral. But they do contribute towards the overall mass of the atom. Electrons are negatively charged, but they're so small that their contribution to the overall mass of the atom is negligible, or in other words, very small. But the presence of those electrons, or the absence of them, determines the chemical properties of that atom. The number of protons present is our atomic number, and for every positive proton there is normally a negatively charged electron. The atom then normally has no overall charge, as the electrons orbit in the nucleus in shells or fixed rotations equals the number of positive protons. Here we have a carbon atom with 6 positive protons and 6 negative electrons. Plus 6 added to minus 6 gives us 0 or no overall charge. These electron orbits or shells can only have a fixed number of electrons. So there's a maximum of 2 electrons in the very first inner shell, then 8 electrons in the maximum in the next shell, and the next shell up again is a maximum of 8. So when we fill an orbit up with electrons, we simply move up to the next shell. One way an atom can gain a full outer shell of electrons is gaining electrons to fill that outer shell, or losing some to drop down to the energy level or shell of electrons that are below. Atoms that gain or lose electrons make an ion, or a charged atom. An atom could lose an electron and become positively charged. This loss of an electron is called oxidation. So here, a hydrogen atom is losing an electron, becoming a positively charged hydrogen ion. It's positive as it still has the one positive proton in its nucleus, but it's now lost the negative electron that orbited it. We represent this in chemical symbols as a small plus sign, in superscript after the chemical's letter or letters. So in this case, hydrogen, represented by the letter H, becomes H+. Calcium often loses the 2 electrons in its outer shell, as this shell isn't full. By losing these 2 electrons, it will become a calcium ion. It's now got a full outer shell of 8 electrons, but it's still got those 20 positive protons in its nucleus. So now it's got an overall charge of +2, as the 20 positive protons minus the 18 negative electrons equals +2. So we write this as Ca2+. If an atom gains an electron, it will have an overall negative charge as it's gained an additional negative particle. Here, sodium loses the electron in its outer shell, so sodium has been oxidized, and the chlorine atom gains that electron. This gain of negatively charged electron is called reduction. The chlorine atom is reduced, becoming a chlorine ion, or Cl-. So we now have a positively charged sodium ion and a negative chlorine ion. These opposite charges are attracted to one another and form an ionic bond. So sodium chloride is produced, or in other words, common table salt. An easy way to remember the rules of gaining or losing electrons is by using the acronym OIL-RIG. So oxidation is loss, so that's loss of electrons, and reduction is gain of electrons, hence oil rig. It's not just atoms that can become ions or charged though, small molecules can do it too. For instance, the molecule calcium carbonate, CaCO3, is a white compound occurring naturally as chalk, limestone and marble. Calcium carbonate is made up of one calcium atom, one carbon atom, and 3 oxygen atoms bonded together. We have seen previously that carbon can bond with one oxygen by sharing 6 electrons to form a triple covalent bond seen in carbon monoxide. Carbon can also covalently bond to 2 oxygen atoms to form the molecule carbon dioxide by sharing 4 electrons with each of the 2 oxygen atoms, forming double bonds. However, carbon can also bond to 3 oxygen atoms. By bonding to 3 oxygen atoms, the carbon is stable, as it has 8 electrons in its outer shell, as it gains the 4 electrons it needs by sharing with the oxygen atoms. This carbon-oxygen bond on the left is sharing 4 electrons to form a double bond. So the left-hand oxygen is also stable. It has a full outer shell of 8 electrons. But the 2 other carbon-oxygen bonds only share 2 electrons each. So these 2 oxygen atoms are unstable, as they both need 1 more electron each to have a full outer shell, as they only have 7 electrons even after sharing some with the carbon atom. So these oxygen atoms can gain the electrons that they need from other atoms. Here, calcium donates the 2 electrons. Calcium doesn't want them anyway in its outer shell, it wants to lose those 2. So by losing those 2 outer electrons in calcium atom, we create a positive ion. It's then attracted to the 2 oxygen atoms that have gained its electrons, as they're both negatively charged. Again, we formed an ionic bond and produced a new molecule, calcium carbonate. A geologist would tell you that calcite, aragonite and vaterite are pure calcium carbonate minerals found in rocks like limestone, chalk and marble. But calcium carbonate is important in biology too. Many invertebrates such as mollusks, corals and echinoderms such as starfish and sea urchins, well, they construct their exoskeletons from this mineral. And all vertebrate eggs laid on land, so amniotic eggs, except turtles, have shells made of calcite, which is a crystalline form of calcium carbonate. Turtles actually lay their eggs and they're made of aragonite, which is another form of the same mineral, calcium carbonate. But more on this another time. If that's been useful, please like and subscribe. I've been Jungle, and this has been another episode of Biological, where we make the study of life science a little bit more, well, logical. Till next time.